Great. So then let's move on to presentations. And what we've got next is some quick fire presentations, which are examples of social research in the air quality space. And our first speaker, hopefully, is going to be Professor Steve Yearley from the University of Edinburgh. You're muted, Steve.
Yeah, no, I was saying I'm muted. I'm just... okay, so I think Fleur is going to... I sent my slides to Fleur. She's going to... Okay, can we go to slide 1, please?
Yes, there we go. Is that looking okay?
Okay, thank you. Great. So, hello, everybody. My name is Steve Yearley. I am at the University of Edinburgh, where I've been for 13 or 14 years. But before that, I used to run the sociology department at York. I obviously left at a bad time because air quality came even more strongly after I was there. But I had 2 or 3 projects on air quality issues, particularly with the Stockholm Environment Institute people who have a base at the University of York. And we did work on urban air quality issues in a number of cities, including Sheffield, Bristol, and York. So some of the things I want to say relate to that, but I haven't really been doing detailed empirical work in this area really since I moved to Edinburgh, and so I don't have very recent detailed empirical work to talk about, but also I'm open very much to returning to this area. So can we go to the next slide, please? Thanks very much. So essentially, I wanted just to say, by way of a starter here, that it's clear that there's a kind of a change in the policy issues and the kind of politics around air quality. So when I started working on these issues back in the 90s, I guess was a point of change. You can see here on this graph, which comes from DEFRA, showing the sudden increase in the number of monitoring stations during the 90s. So prior to this, there was a series of arguments around, who set the thresholds and what scientific justification there was for thresholds, and also how monitoring was being done, so that at the time that I started, somewhere like Leeds or Sheffield might only have 2 or 3 monitoring stations. And so they were making claims about a whole cityscape based on very few measurements. In the 90s, essentially the argument goes, or the practice goes spatial, so that they have mobile monitoring stations and people become interested in trying to get an overview and also an obligation to understand air pollution issues across a city region spatially. And also there's more work that's done on exactly understanding transboundary, so low-level ozone that comes in from the countryside and so on. And the other thing that goes on here, as I'm sure everybody knows, is that there were all these projections about the direction in which air quality was likely to go as a result of particularly restrictions on pollution that was expected to come from motor vehicles. But a lot of this from Euro 4 and 5 standards didn't appear as was anticipated. And of course, with the Volkswagen and other emission scandals of 8 years ago or so, you had this widespread recognition that insofar as progress was expected to relate to reduced emissions from vehicles, well, then the way in which vehicles were tested wasn't really going to help with this, because often the NOx emitted from vehicles was much higher than was shown in test sites. So what you get over this period is a change in the nature of the targets, the nature of the politics and arguments around this, and a change in the expectations of what can be achieved. Next slide, please.
Is that working?
Oh, yes, sorry, it is, beg your pardon. So air quality knowledge. So I said my talk is going to be about knowledge, practice, and difference. So I've just got 3 slides to go now. So knowledge. So one of the things that I was interested in from when I was doing the studies was two aspects of knowledge. So one is, of course, air quality policy depends on a lot of knowledge for which common sense doesn't really equip people. It's difficult to know, NOx or other pollutants in your area. Your senses aren't really adjusted for this. So you're dependent on official measurements and so on. But of course, there's a lot of issues around how much you can trust the people who are doing the measurements, about where they site the monitoring stations, about how well they're maintained, and all that kind of thing. So there's a big question about sort of trusting expertise around knowledge, and of course the influence of environmental NGOs becomes very important in this. So a key example was about the arguments around Heathrow extension, when, for example, the argument was successfully made that expansion of Heathrow would, because of NOx emissions from planes and also the increased amount of traffic that would be going to the airport, that you have this air quality reason for resisting expansion of Heathrow. The second thing I want to say under this is that, and this came out very strongly in the studies I did with the SEI people, is that you have a question around citizens' own understanding of air quality. So that one of the things that was kind of interesting was, as the cities of Sheffield and Bristol were developing their air quality models and providing communication around what their models were projecting, we were interested in how this fitted with or didn't fit with people's understanding of their air quality surroundings, so that people would have quite strong feelings about the difference between air quality in their front and back gardens, for example, which weren't necessarily resolved at the level of the model. And so this gave people their own, it both gave them resources that they could bring to discussions about this, but also fed into the credibility that they attached to the models if it didn't seem to conform to their own reality. And then finally on this, when we were doing these studies, of course, people didn't really have, smartphones weren't available, people weren't connected to the internet in a way that is routinely thinkable now. And so one could, and I know Jennifer will talk about this a bit, but one could think about novel ways of having dialogues with citizens that are based around citizens as continuously in touch with monitoring technologies through their phones and other digital devices. And of course, this gives rise to novel possibilities around citizen science initiatives, where you're using sort of crowd science and so on to provide data for collaborative or bottom-up kind of modeling initiatives. The next slide, please. So air quality practices. So this is a lovely picture of the conference centre at the University of Edinburgh with some charging points outside. So when I talk about practices, I'm referring to a bunch of ideas that have come forwards from social scientists that many people will know about. But essentially, the practices kind of approach started out as a criticism or a critique of the way in which behavior change was often thought of. So a woman at Lancaster very successfully put forward this argument, which she has a kind of slogan about the ABC, where she said most approaches tend to think of this in terms of addressing ABC, changing people's attitudes, changing their behavior, and encouraging them to make the correct kind of choices about their technologies. But the point that she made, and other people have made, but I think is a very strong point, is that this conception of behavioral responses is too individualistic, in the sense that it focuses on people's attitudes, their management of their own behavior, and getting them to make the correct choices. Whereas in a lot of cases relating to air quality and air pollution, although these arise from things that people do, their travel or they're heating their homes or their commute or the way they take their children to school and so on. Often their choices about these things are not really made autonomously. So that, for example, how you heat your home is not going to be down so much to your choice. It's likely to be down to what your heating engineers or builders suggest, or what local DIY shops stock, or what transport authorities do to make commuting options available. So that the important thing here, and I mean, she uses the terminology of practices to refer to these ways in which people's choices are kind of funneled down customary channels, because although people are in a sense autonomous, they're not really autonomous in many of these areas because they depend on other kind of agents or decision makers in order for them to be able to conduct their behavior. And just to give a completely anecdotal, but for me it was very interesting. I sadly have a gas boiler, and I was talking to the heating engineer who came around to do this, and he was saying, oh, because of Scottish legislation, we're not allowed to fit any more gas boilers after next year or something. And I was saying, you know, so what are you going to do? And he was completely blank about this. I mean, he had no idea about other kind of options. And so just that sense in which all his customers' choices will be refracted through what he, you know, it's not their choice so much as the position that he finds himself in and how he stands with regard to the legislation. Final slide, please. So the final thing that I wanted to pick up on that I think social scientists are increasingly thinking about, and I guess this is, you know, as I said in the notes, this is often thought of, I mean, this is becoming increasingly popularly known because of publications about invisible women and so on, which won that, I mean, the great book that won the Royal Society Book Award. But that although our way of thinking about many of these issues acknowledges that there are different, you know, there are differences between people, and of course, if you want to send a message or devise a policy that motivates people to change, well, you need to think about people in a statistical way. I mean, they're all individuals, of course, but maybe you can think about differences between them statistically. Or often for these things, people are thought of as members of households, you know, since a household tends to have a gas supply, a heating system, and so on. But I think there's an issue that these this way of framing it overlooks systematic differences, where differences in this sense might refer above all to gender, but they could also refer to ethnic and what we might think of as racial differences, or they could refer to generational differences. So that the way in which a household thinks about, you know, let's say, take the example of fires and barbecues and so on. Of course, at one level, these are down to people, and one needs to think about, you know, maybe having incentives to get them to do less polluting activities. But it's also important, I reckon, to think about how the gender division within households play out in, because, you know, as I mean, as a part of management of outdoor fires tends to be much more a guy kind of thing than it does to be a women's kind of issue. So that we need to think about the ways in which the things we're trying to affect map onto these other differences, whether that be gender or ethnicity or generational and so on. So I think I'll leave it there. Those are my 3 points about people as knowledgeable, about practices rather than individuals, and about being alert to difference, whether that is gender or ethnicity. Thank you very much indeed.
Thank you, Steve. As Fleur said, we'll take questions in the chat. So if we could now move on to our next presentation, which is from Professor Jennifer Gabrys from the University of Cambridge.
Sorry, my just trying to get my mute panel to come down. Thanks very much for the invitation to present quickly work on social research and air quality. It's great to see so many people attending, and also thanks to Flor and the STFC for organizing this event. I'm going to speak specifically about work that I've been doing for around 8 years or so on citizen engagement in air pollution, specifically looking at citizen sensing. So this work began through a study, an ERC funded study on citizen sensing. And it initially was looking at a broad range of sensors and the rise of environmental sensors. But we quickly found that because air pollution is such a significant problem worldwide, that there was a lot of movement in developing sensors to monitor air quality and for citizens to be able to observe and document air quality in the ways that Steve mentioned, perhaps because they might not trust official data, or also because there are not monitors in locations where people would want to know what sort of pollution is occurring. And of course, air pollution contributing to all sorts of health problems, contributing to as many as 1 in 9 deaths worldwide. So this is where the Citizen Sense project came in, looking at how citizens are developing practices to monitor air quality, how they're using sensors to do this, the extent to which sensors are helpful or problematic in terms of collecting data, in terms of organizing different kinds of environmental participation and citizenship. So what do these sensors enable? What do they potentially delimit in terms of making air pollution potentially primarily a problem of measuring? But then how might this also be approached through developing participatory and practice-based methods for undertaking engaged social research? So here we were looking at not only how do citizens engage with technology such as sensors, but how can they come to understand relatively opaque for most people science, which is atmospheric science. It's not something that's sort of in everyday discourse. So how can people even begin to start to monitor air and understand the data that they're gathering and actually act on this in some way? So this is part of the trajectory that we were looking at as well, is not just studying the social and studying social practices, but how to collaborate with communities to monitor air pollution, to learn about incidences where this is occurring, how to analyze data, communicate findings, and even, as we found with our research, to propose transformations to environments. So I think this is one of the most significant things that we found from this research is not only can you gather data and learn about what's in the air, but this can also help you to understand in quite a situated way how to change environments to improve air quality. So if you're interested more in the overview of Citizen Sense, you can go to our website and see more about how we went about researching citizen monitoring that was already occurring. For instance, many people using diffusion tubes to better understand where air pollution was occurring, and then attempt to form various campaigns to stop or redirect, for instance, national infrastructure projects and so on. But from that work, I wanted to discuss today a slightly more up-to-date project we're working on. We're actually just in the process of launching a proof of concept project that has also been funded by the ERC called AirKit. And this is a study where we are taking all of the various components that we've developed from Citizen Sense and developing or attempting to develop a citizen sensing toolkit that can allow communities to set up their own air pollution studies, to install and even build, if they're so inclined, a citizen sensing monitor called the Dust Box, which allows them to sense particulate matter, temperature, and humidity. We have a logbook that we'll be launching that goes along with this. And we've also designed a platform that allows people to view their data, to add observations, and to write data stories. So this is a key technique we've used to allow people to not only analyze data, but to craft narratives and most importantly, proposals for air quality action where they can mobilize their data to act in particular ways. So we've studied this with, or piloted this air kit with communities in Forest Hill, where we installed these dust boxes you can see in a variety of locations. So part of one of the kind of key questions I always get is, are these dust boxes calibrated? And how do you know the data is accurate? So what part of what we then sought to do is also develop a DIY method to undertake your own calibration. So we went through and tested a method for renting your own reference monitor, and setting that up to establish that you have good correlation. And so this is also in the logbook, where we found that our dust boxes have a very high level of accuracy. So you can read about that on our website. The logbook then provides a resource for understanding air quality as a planetary health problem, looking at existing monitoring networks, building your own sensors or loaning them from us, analyzing and storing your data. And here's I guess a preview of the platform that we're just about to launch, called AirSift, which, as you can see, allows you to look at your dust box data, to look at other people's observations and add your own observations, so that there is a kind of qualitative component of adding your insights about air pollution, whether that's in relation to news reports, health, various construction activity, and so on that might be occurring in the environment. And just to say that this map is worldwide, so while we're starting in the UK, it could take place in any location. You can also see real-time live analysis of your dust box data over the last 24 hours, or you can undertake a more historic analysis of your data for its entire duration of the monitoring period. And you can also add your own stories if you want to narrate the data that you have collected, and you can do this in a collective way. So we're allowing people to think about how they want to create narratives about their locations that could be part of a community project, and so on. So here you can see an example of the last 24-hour period data. And if you go under the analysis tab, you can also look at more historic data. What we found in the process of making this platform is there are just so many opportunities to collaborate with people in atmospheric science and technology to bring in multiple other forms of data. In a more historic AirSift version that we made, we were bringing in London Air Quality Network data. We also piloted a prototype where we brought in purple air data. So of course, we could bring in lots of other data through APIs, lots of other wind and weather data, temperature data that would be useful to analyze along with this material. So I think there's lots of opportunities here for creating interoperable data sets, as well as environmental data that might help people support their proposals for what they'd like to do in environments. Given that my past life was as working in landscape architecture, I'm always interested in these intersections between sort of gathering data and how it might then be used to propose changes to the built environment, which of course is more important than ever in the current circumstances we find ourselves in. So just to quickly show you the methods we used for this community collaboration. We looked at the problem of air pollution in London, as you know, largely due to traffic, but also there is a fair amount of regional pollution that London receives from the continent, from easterly winds. We then worked with communities to do field work, walk around Forest Hill, look at monitoring locations. If you know this area of Southeast London, it is heavily influenced by the South Circular Road, major thoroughfare in London, which will be affected by the low emission zone and the ultra low emission zone proposals and developments. We then installed dust boxes. We also have guidance in our logbook for how to build your own Stevenson screen if you'd like to save money on these very inexpensive structures. I'm not sure why, but you can build them quite cheaply with the guidance we've provided to keep your dust box super weatherproof, although they are weatherproof. And here's the monitoring setup that we did at a very limited number of locations because we were disrupted due to COVID. So we were only able to get a few dust boxes in the field before the lockdown hit. But then we did work with Lewisham Council and Skanska to install additional lampposts, additional dust box on lampposts, which are still in the field now. And we did 2 preliminary, what we're calling COVID data stories, since we were so affected by COVID in collecting this data. And we're showing that there was a certain decline of particulate matter in the citizen data sets that we gathered, but it wasn't nearly as significant as declines in nitrogen dioxide. And the data stories put forward why this is likely to be the case, which is due to these regional and seasonal agricultural pollution events that were occurring in sort of April time, which very much influenced the data set. So we worked with participants to look at this data. We held a workshop to put forward actions for what to do next. And we found that this really has so many opportunities for social research and air quality going forward. Of course, this allows for the building of citizen-oriented infrastructures for not only monitoring, but also acting on air pollution. It's a way to experiment with techniques for interpreting data and developing interoperable data sets. So this isn't merely about measuring to show compliance with regulatory thresholds. This could be about measuring for very particular purposes to show that pollution is occurring in a busy thoroughfare that people want to address. This is then a way to organize and act on citizen proposals for transforming environments. It can very much align air quality science and policy with citizen engagement. So this is a way to not simply distribute information about air quality to the masses, but instead to involve people in ways that ensure more democratic, just, and pluralistic approaches to air quality. And I think in this way, it can really transform social, scientific, and technical research through these different approaches to public engagement with air quality. So of course, just a quick credits and contact slide, very much helped here by postdocs Joanne Armitage and Sachit Mahajan. I should note that here we have expertise in humanities, social science, computational social science, as well as computer science and electrical engineering with postdocs on the team. And thanks, of course, to the participants and organizations and our collaborators, including developers who helped with the data architecture and the 3D design of our dust box. So looking forward to the breakout rooms and discussing this more with people.
Thanks, Jennifer. And our next speaker is Professor Nigel Gilbert from the University of Surrey.
I'm going to be talking about a project called Anticipate. Unlike the previous 2 presentations, which were emphasizing the importance of linking in citizens, Anticipate is essentially directed at policymakers and policy. And the idea is to bring together policy analysts and policymakers within the UK, from central government and devolved administrations and so on, and business stakeholders to think about the consequences of policies on air quality, consequences either positive or negative. And when I say public policy, I don't mean public policies about air quality, I mean public policies about all sorts of other things. Everything from net zero to, as we shall see, innovations in the NHS. So the basic idea is that if government is going to be making policy changes, then we should think about what the consequences for air quality of those might be. And the way that we've been doing this is to essentially engage in workshops involving policymakers and other important actors, stakeholders, to think through these. And one of the outputs of the project is a how-to guide, how one should involve such people and get them to think slightly out of the box about air quality issues. So we have a sort of flowchart in which, having chosen a policy to investigate, to examine, we start off by mapping the stakeholders who might be involved, we want to participate, their relative influence on the policy. We contact these stakeholders and find participants for our workshops. We hold what we call an inception workshop, bringing the people together, summarize what happens there, select issues from that, bring in air quality experts to look at the implications of the policies, possibly invite further participants, and then have a follow-up workshop, and eventually write a briefing and distribute the briefing with the intention that the policy being considered should be changed or refined to draw out the favourable and mitigate the unfavourable effects on air quality. So that's the sort of general idea. We've been through that cycle once with something called the NHS app. Actually, this was before COVID. We all know about the COVID app, which does test and trace, but this is the NHS app also exists and is actually really useful. It's available to the public. It's being developed as we speak. It allows you to do things like check your symptoms, do an equivalent of an online 111 call to identify what might be the matter with you. It allows you to book GP appointments and a number of other things of that kind. When I was looked at about 5 million users of the NHS apps, so it's quite a significant thing. But what we were interested in was what the impact of the design of the NHS app might have on air quality. So we held an inception workshop in which the stakeholders included the developers of the app, people from NHS Digital, GPs, as well as air quality experts, which generated an overview of the current plans and an initial set of potential consequences for air quality. Did this by brainstorming factors, that's anything that might vary that would be relevant, enablers and inhibitors. We looked at the structures, the practices, going back to what Steve Yearley was talking about, social practices, attitudes, perceptions, and the interactions, and aim to define causal linkages between the various factors that were identified. And that was followed by a follow-up workshop, which refined what we ended up with a system map and proposed mitigations and alternative options. And then finally, we produced a paper that was sent to the NHS, to the Sustainable Development Unit of the NHS, to the NHS Net Zero Initiative, to the Public Health England, and so on, which listed some key recommendations arising from this work. We were just about to set off to a second policy when came COVID. And as you will have seen, the activities that I've been describing involve a lot of face-to-face interaction, and suddenly we couldn't hold workshops anymore. So one thing that we've kind of pivoted to is to try and do these workshops virtually. And to help with that, we've been developing some software, which we call the Participatory System Mapper, or PRISM, which allows us to develop these kinds of system maps. So each of these bubbles represents a factor, and the arrows between them, the causal linkages. Now, there's quite a lot of software out there which will allow you to draw these kinds of maps. The thing that makes it different, this particular piece of software slightly different, is that you can run it in your web browser collaboratively in real time with other people. So as I move things around on my screen and add in factors, the same thing will appear on your screen and vice versa. There's a bit like using, as we were doing right at the very beginning, when you put in your name and your email address, everybody was using that same Google Doc simultaneously and seeing what everybody else was doing. Well, that's the same idea with this software. So you can actually have a collection of people, of stakeholders, working remotely and collaboratively developing these kinds of system maps. We normally use this in conjunction with Zoom, so you can see each other and talk to each other, although there's a kind of chat window built into the software as well. So we're beginning to learn about how to run these kinds of online workshops. And here's a quick summary of some of the things that we have been learning from this. First of all, and perhaps not so surprisingly, that this works best when people already know each other, already have established relationships with each other. And secondly, that it's important that one has a clear idea. People, policymakers and stakeholders of the kind that we are interacting with are inevitably extremely busy people with all sorts of priorities. So it's important to make very clear what they will get out of the exercise. In fact, our experience so far is that they really love it when they're actually in the room or in the interaction. They find it very revealing to see other people's perspectives and to understand how their perspective clashes or merges with other people's interests and ideas. And then that it's actually quite important to have small groups rather than large ones, and that a sequence of workshops, a sequence of meetings is the way to go. So that was a very brief introduction to what we are doing. I'd like to finish off by acknowledging this is very much a collaborative exercise, this project, including Sarah Mollo is, of course, our chair today, as amongst the co-investigators. I'd be very happy to talk more about how people could use the software that I briefly described and the methods that we are developing for running these stakeholder workshops for system mapping. The software is open source and freely available if you're interested. Thank you.
Thanks, Nigel. Okay, so now we're going to move on to a section where we've got a panel of people from STFC, And we'd like to get some reflections from them on what they've heard, on where they think there might be opportunities for STFC to be involved, to, as I said, to augment, to help with joining up with any of this sort of research. So I guess, first of all, might be just to ask people to very quickly introduce themselves who are on the panel. So we've got 4 people, Marion, Hugh, Wendy and Stefano. Could I ask you just to very quickly introduce yourselves? So perhaps Marion goes first.
Okay. Hello, I'm Stefano. I work in STFC in the Scientific Computing Department. My expertise is mainly related to modeling, fluid modeling, and high-performing computing.
Thanks, Stefano. Marion?
Hello, everyone. Really good to see you all. I'm Marion Samler. I think maybe some of you know me. I'm the Daphne Partnership Manager. I also work in the Scientific Computing Department at STFC. And I'm here representing Daphne today, the Data and Analytics Facility for National Infrastructure, and some excellent conversations or presentations so far. I can already see lots of links. So thank you.
Hugh?
Yeah, good afternoon, everybody. Thanks for inviting me to be a part of this. So I am Hugh Mortimer. I'm a research scientist working in RAL space in STFC, and my focus is mainly on developing instrumentation for remote sensing from a variety of different platforms, from UAVs through to Earth observation. But I'm also a huge advocate for projects that are very interdisciplinary, such as the ability to bring in social scientists, economists, anthropologists to help support the development impact agenda of the work that we do. And so I'm hugely a big fan of this. But also I want to note that I have also worked previously on scientific communication, and I'm massively passionate about communicating our science to the general public. So been involved in collaborations with artists in the area of air quality. So for those people who know, there's an international program of work, art collaboration called Invisible Dust, that brings scientists and artists together to make some incredible pieces of work. And so, yes, I'd like to promote that wherever possible.
Thank you. And lastly, Wendy.
Good afternoon. I'm Wendy Garland. I work for the Centre for Environmental Data Analysis, which is based at STFC, but also funded by the NERC. I work with atmospheric and Earth observation data. My speciality is airborne and atmospheric composition observations. So we're a big data archive and a compute platform available as well.
Okay, so then if I can just open it up for anybody on the panel to kick us off with some reflections on what they've heard and any ideas that they've got for the role of STFC.
Will I go first then?
Yeah, go on, Marion. I thought it was very good.
Sorry, I'm itching to go first. Sorry about that.
Yeah.
So I put a comment up on the chat, and I think there's some great links there. I mean, with some of the work we're trying to do on, we've got this project called Open Climate Framework Project. It's done in collaboration with the Tyndall Centre for Climate Change Research. And what we're trying to do is bring some of the modelling that's with this along with some of the data. And we're very much, I think, hoping to work with CEDA Jasmine in partnership with this. So I think there's some great connects there with linking with other data centres and then bringing on researchers to help provide a suite of modeling tools. So we're putting a lot of energy into trying to integrate models together so we can give this systems modeling approach to analysis. So I think that's, Jennifer, I think I've put a note up for you in the chat. Hopefully you've got a chance to look at that. I think you're holding quite a lot of data there that might be of use to our researchers, and likewise we hold data that might be good for your researchers. So I think there's potential there to collaborate, definitely.
Shall I go next?
Yeah.
Okay, so as I mentioned before, I have worked with social scientists, economists, mostly in the area of biology, ecology, but I think the actual philosophies apply, the methodologies apply very pertinently to this consortia, and I think I know I'll be preaching to the converted here because we've got a group of people who have already been enthused by this to be enough to be in part of this workshop here. But from my perspectives, I think there are definitely different models of working between physical scientists and the sociologists and economists, but for the massive benefit of everybody. I think the ability to, if you're thinking from a scientist perspective, from a physical scientist perspective, someone who is developing instrumentation, someone who's looking to deploy observations in a more robust way that is useful for the end user, then the ability for sociologists, economists to model and to understand how you can use those technologies more effectively to improve the collaboration and to communicate those outputs to a range of stakeholders, it's clear that it needs to be done in an interdisciplinary way. And I think as a physicist, I don't necessarily have the skills to actually to make those connections, to make the work that we do more impactful. And it has to be done in this way that we bring together all of the people who have a role to play, to maybe to create new communications channels or to help facilitate kind of collaboration between stakeholders. So I think this is whether it's a case of SGFC bringing data to people who need it, or whether it's a way that SGFC works with economists and sociologists to highlight just to highlight the fact of what we have physically got that can help support some of the questions that they may have. I think there's a whole range of things we can potentially do.
Brilliant. Anybody else?
I say at CEDA, we do have several air quality data sets that might be of use to the community, and along with the data that Marion has in Daphne. Our data is collected mainly by academic research projects of various kinds, and what we are trying to do is to collect together enough metadata to support these measurements so that they can be used more broadly for different purposes than they were collected for. So we need to know information all about the instruments and the platforms to make them as widely reusable as possible. So as Jennifer was mentioning, with her website, they've used different data sources. There's perhaps a degree to which she could access some of the CEDA data and put it into her model and be able to interact with different platforms.
If I may add something, going a little bit tangent and describing something that STFC and a bit more in general UKRI, I think mainly STFC and DPSRC, capability that we have got and I think has not really been explored in the previous presentation is try to use large scale modeling and simulation in order to help policymaker and enforce, try to understand the effect of policy. I think that in the atmospheric sort of atmospheric communities mainly use only for climate modeling, but I think there are potential to also extend it to more air quality sort of application. A lot of times I can see trying to bring together use of sensor with policy. If we could also some larger scale modeling in there, it could after tapping into some of the STFC capability in our department. And I think more in general in UKRI, some of the UKRI capabilities that maybe have not been explored and used so far.
Did any of the speakers want to respond to anything that was said there?
Sure, Steve, here, if that's okay. So
yeah.
I just take my hand down. I put my hand up. So I think that's great. I just made me think of three things. Sorry, I've had to move in the house, so that's why I've got the Bay Bridge back again. I know Nigel talked about this a bit, and I think Jennifer and I could have done, but it occurs to me that one thing that's very interesting that comes through here is a question about the link between research and policy making in these areas. So, of course, everybody in different ways is interested in producing knowledge that is potentially useful for policy purposes, but there's that sort of meta question about how this connection is actually made. So I think Stefano was addressing that in part just now. And of course, one of the issues here has been that although there's been a big increase in the understanding of air quality issues, in a sense, the policy has kind of got stuck because there were these expectations about improvements of emissions performance, which didn't turn out to be realized. And so it's not that there's an absence of evidence, there's an absence of a way of sort of resolving the problem of how to make novel kinds of policy with that will succeed given the kind of evidence we have. So I think that there's one interesting question about the link between science and policy. And as Stefano said, we think about that a lot with regard to climate. So how does the IPCC use evidence that then gets mobilized for the UNFCCC to do things about countries' climate policies? But I think there's a big issue there in air quality also. And then I think there's also another issue, which is to do with the connection between the knowledge that's available and the sort of local credibility. So I think one of the things that's interesting about Jennifer's work is the sense in which people's engagement in installing the devices and then monitoring the data is simultaneously a part of reorienting their life around these questions of air pollution. So in a sense, one is doing it not just for the quality of the data and the understanding, but that it gives a new dimension of engagement with these issues. And so I think sometimes when we think about these activities as leading to data, well, yes, they do lead to data, but that's maybe not the most interesting thing that they lead to. So that I'll leave it there. Just a couple of thoughts.
Steve. Nigel, you've got your hand up.
Yeah, I just wanted to suggest that one of the ways in which policy has been failing has been that for one reason or another, the policies have been very kind of narrowly focused. That when making the policy, for one reason or another, it may not be, it's probably not stupidity, it's more politics. The policies have pushed one lever, but failed to notice that something else is going to happen as a result. So, the classic example, of course, is the shift to diesel, which was there to reduce global greenhouse gas emissions, but had the effect of increasing NOx emissions. And it wasn't the case, just to reinforce what Steve said, that people didn't know that diesel produced more NOx than petrol. It was that issue wasn't considered as part of the equation when thinking about that policy. And another example is wood burning stoves, which were promoted by the government because they used renewable energy. but actually they're producing enormous amounts of PM 2.5. Yeah, we're seeing the same sorts of things now with the efforts to produce clean air zones in cities, where the unintended consequences of some of these is probably going to be worse than what it was trying to alleviate. So all in all, I mean, this is really a sort of plea in a way for looking much more widely outside the silos of government departments. And I think this is one of the areas where academics can help lead the way, because they do have a wider vision than the people sort of looking inside particular policy areas where everything else except their particular policy area is off the horizon, out of the horizon.
I mean, I can just jump in there as well. I think what this panel is really showing is that there are a lot of opportunities to do air quality differently, or to expand approaches so as to actually improve air quality. So the various suggestions have been made about modeling and data. I think those are really fascinating when we put those in the larger context of how we might then join up with policy, as Steve and Nigel are suggesting, and actually shift the ways in which air quality is dealt with. And we're at a really critical moment now, of course, in the UK, and of course, this is an international audience here today, but in the UK, looking at the Environment Bill and thinking about what will the standards for air quality be, but also how will air quality be addressed. So I'm really interested in the ways in which there might be these pilot projects to really test the ways in which new kinds of infrastructure, new kinds of knowledge practices can be developed to act on air pollution in a way that can really improve the situation by, for instance, transforming urban environments, by looking at the ways in which air polluting activities could be changed and made less extreme, really. So I think there are a lot of opportunities with the modeling and the data to look at what those possibilities might be, even through really situated experiments. And the thing is that publics are already doing these things. You'd be amazed at how many community groups and schools and other kinds of organizations. Steve mentioned environmental NGOs, but many other organizations are already putting up green screens. They're looking at traffic calming. They're involved in the low traffic neighborhood initiatives. They're undertaking all kinds of experiments in their environments and really trying to study and understand what the consequences of those are. So really, it's interesting how people are not wasting any time in really trying to address air pollution in these very situated environments. And I think there's a lot of opportunity to work with people to see how these infrastructures can help with those studies.
That's great, thank you. We've got a couple of minutes left, so is there anything that the panel want to come back on from an STFC point of view?
I think as much as anything, it's about for STFC, and I think STFC to try and get a kind of a better strategy about is how we communicate to communities who don't necessarily know what facilities and technologies that we have available to us, to do that more effectively and to enable everybody to understand what we have as a resource that the UK academic but also industrial communities can come and make use of, everything from the high performance computing and modeling capabilities through to the data sets that we have. And I think we've got a lot of passion and will to make use of these in any scenario, as long as it kind of it helps where it's needed to be helped. And I think this is a great example of this kind of air quality question, where we have environmental data sets and we have the ability to model large-scale systems, so we can potentially bring in questions about economic challenges, policy-making decisions, in a way that we can actually then have an informed decision based on scenarios that you can model into the future about optimized ways of employing or deploying observations, or things that these unexpected consequences of switching to diesel that you can potentially model and then make a decision on. And I think that's the kind of thing we want to get across is we do have these technologies and they are available to be used.
That's great. Thanks, you, Steve.
Thank you. Yeah, no, I thought that was great. So again, I'm sorry, I seem to think in twos. So 2 points. I thought the thing that Hugh was just saying is very interesting, and so the point about being able to use this material to do scenario modeling and so on. So in the case study work that I did with the Stockholm Environment Institute people, there was a lot of demand or push from citizen groups that we engaged with to say, well, if the city council is so knowledgeable about these trends, why are they not used more in making planning decisions? So, when they decide where to site a supermarket, what do they do about using the model to work out the distributional consequences of air pollution from the traffic and deliveries and so on? So I think that this issue about trying to open up ways of thinking about projecting scenarios into the future. So clearly the data and the modeling gives us strong capacity for doing this, but you could think about opening up the question making. I mean, so the design of the scenarios in a slightly more radical way, so that you have more voices in regard to what the scenarios were. And then my second point was really going back to what Wendy was saying about the integration of this into broader environmental data analysis. A lot of what Nigel and Jennifer and myself have been talking about has been very much focused on explicitly human-centered environment aspects of this. But I think it would be interesting to think about the broader, the social science of the broader environmental impact of air quality, not just on humans, but on the environments that we enjoy or value, or the amenity that we derive from them. And I think that a lot of the citizen engagement ends up talking about this as a kind of a health and a health inequalities issue, whereas there might be things about the broader environmental impacts that are of interest, whether that is on valued habitats or on other forms of life on the planet. Thank you.
That's great. Thanks, Steve. Thanks to all the panel for your contributions. I think we need to move into breakout rooms now to have a bit of discussion from other people in the meeting about what they see as opportunities, areas that they would like to look at, linking up what's done in the social science space and other spaces around air quality and what STFC can do. So if